Okay, so I'm going to be going through a bunch of this review sheet, whether you're going through it for the first time or referring back to it as you study for the test or for the Math 3 final. Either one, okay? Starting off, we're going to be doing some quadratic regression. And what we have here is that we have a table of data. It's talking about the wavelength in meters and then wave speed in meters per second. So how long are the waves versus how fast are they going, and can you use it to predict? Okay, of deep water ocean waves. It tells you to model it with a quadratic function. Okay, graph the data and the function. Use the model to estimate the wave speed of a deep water wave that has a wavelength of 6 meters. And so we're going to break it up into each of these parts. The questions kind of guide you through it a little bit, but I'm going to help you out. Okay, so starting off, anytime you're trying to do quadratic regression, what you need to do is actually go to stat edit. Okay, so stat edit. What we're going to do is we're going to put in the numbers, the values that we think are the predictive ones, the ones that cause the other one or correlate to the other one happening. Those go in your X. Okay, so a lot of times this will be the first row or column of your data. That goes in L1. And then the dependent variables are the ones that happen because of the independent or because of the X values. That goes in your Y. Okay, so make sure you have it all in. Pause the video until you do. Line them up. Make sure, it doesn't really matter what order you go in, but the left and the right have to match up. So 3 has to go with 6, 5 has to go with 16, 7 has to go with 31, and so on. Okay, so next, in order to do regression, what we're going to do is look at stat, calc. Okay, stat, then calc, and we're looking for the one that fits the model that we said. So a quadratic function is quadratic regression, number 5. Okay, now X list, Y list, make sure it says L1, L2. If you have an older operating system, it might look a little different. Okay, and then the only other thing is where it says store regression equation, you can put in Y1 there, or just go down to calculate. We'll write it in by hand later. Okay, so here you go. A equals 0.589 x squared plus 0.335x minus 0.332. Okay, so predict it. Y equals 0.589 x squared plus 0.335x minus 0.332. Great. 0.589x squared plus 0.335x minus 0.332. Okay, well, predict the wavelength if the wave speed is 20. So we need this in our Y equals, or that's one way we can do it. So 0.589x squared plus 0.335x minus 0.332. Okay, and if we want, we can look at the graph, but really what we're looking for is when x is 20, or sorry, that would be when y is 20. What's x? Well, we actually missed a part from the last one, so we'll back up a little bit. Predict the wave speed when the wavelength is 6. Wavelength, so go back and check, but wavelength is x. X. So what's the speed when x is 6? Well, go to second graph and look for where x is 6. And so we can see it right here. When x is 6, it's 22.882. So that would be 22.882. Okay, well, how about the next one? Predict the wavelength. So predict x when y is 20. This is going to be a little bit harder. Okay, in order to do this one thing that we can do is graph it. Okay, so when y is 20, you can type that into your y2. What's this going to be? Well, we need to probably change our zoom, our window a little bit to make sure that it goes up high enough. We just said that y is 20, so let's change our y max to be 30. Y min is negative 20. And let's see if we can see on the graph where these cross each other. Okay, so we're looking for this point right here that my finger is pointing out right there. So what's the x value right there? Well, you can try to count it. But we have a function built in called intersection that'll tell us that exact x value. So we go to second trace, intersect, and use right to move your cursor over as close to there as you can get within reason. The calculator is going to choose the closest intersection to what you tell it. Okay, hit enter one time, it'll say second curve. Hit enter again, it'll say guess. Hit enter again, and so it told us that the intersection is at 5.59 or around 5.6. Okay, so x equals 5.6 roughly when the wave speed is 20. Okay, so that's that first one. The second one, multiply this out. Well, that's talking about either write it out twice, so 3x minus 2, 3x minus 2, and then do FOIL or box or so on. Or remember, anytime you have this squared, you can do the square double square method. So the first thing is 3x squared. Okay, then it's negative 2 times 3x, which is negative 6, double that, minus 12x, and then the last number squared. Negative 2 squared is plus 4. Now, the reason I wrote this first one out weird is to make sure you catch something. When you do 3x squared, you have to square the 3 and also the x. That's actually going to turn into a 9x squared minus 12x plus 14. Okay, next one. The product of 3x minus 1 and 2x plus 4 is 6x squared plus bx minus 4. What's the value of b? What does product mean? Product means multiply them together. Okay, so what do we get when we multiply together 3x minus 1 and 2x plus 4? Okay, well, by FOIL, the first thing we would do is multiply 3x and 2x and get 6x squared. 3x times 4 and get 12x. Okay, and then the inside and the last terms, negative 1 times 2x is minus 2x. Negative 1 times 4 is going to be a minus 4. So we're left with 6x squared. Now, the middle two terms can combine. 12 minus 2 is 10, so plus 10x minus 4. Well, the question asks, okay, so if the product is 6x squared plus bx minus 4, what's the value of b? Well, we have 6x squared plus 10x minus 4. b and 10 are in the same location. They are the same value, so b equals 10. Okay, the last one we'll do for now. One more quadratic regression. Okay, the table below shows the height of a column of water as it drains from the container. Model the data with quadratic function. Model the data with quadratic function. Okay, so again, putting numbers in, getting the quadratic model. Use the model to estimate the water level. Okay, the water level. So what is y equal at x equals 35 seconds? Okay, well, let's just look at it for now. I'll blow it up a little. Okay, at x equals 35 seconds, you would be right in this range, between 30 and 40 seconds, so between 66 and 50. Sometimes on a multiple choice, that's actually going to be close enough that you can actually just guess the answer from there. Maybe 58, maybe 57. It's hard to say until we actually look at it. Okay, so again, stat edit. Now to clear out your lists, you can move up to L1 and just hit clear and hit down or enter. L2, hit clear, down and enter. Okay, and then type these in. 0, 10, 20, 30, 40, 50, 60. Okay, do the same thing. 120, 100, 83, 66, 50, 37, 28. Okay, now remember how to do a find a quadratic model. It's going to be stat, calc, and then find the quadratic regression. Stat, calc, 5 is the quadratic regression. Now let me show you a shortcut this time. Where it says store regression equation, if you want, you can do this nice shortcut method, which will just put it in for you. Okay, so you do vars, y-vars, function, and then hit enter. And so it'll put a y1 right there. That means put it in my y1 for me. Now, if that doesn't work, you may have something that looks like this, where it says like quad reg, and then that's all that pops up. So it may look something like this. Well, before you hit enter on that quad reg, just do vars, y vars, function, enter. And then hit enter after that. And it'll type all of this into your y equals for you with all the decimals. So it's going to be a lot more accurate than what we had done before. Well, when x is 35, go to second graph. And you can either scroll down to where x is 35 or go to second table set, which is second window, and where it says table start, just type in the number you're looking for and then go back to second graph where the table is. So 57.937 is when x equals 35. So after 35 seconds, it's a predicted height of 57.9. So estimate the water level at 35 seconds. At 35 seconds, the water is around 57.94 millimeters. Okay? So next video.